There's a number buried inside Microsoft's latest Windows security guidance that should make anyone who manages computers stop and read the sentence twice. 3 days, not 3 weeks, not the end of the month, not the next scheduled maintenance window that fits neatly into the quarterly IT calendar. 3 days from the moment a security patch becomes available, Microsoft is now recommending that organizations have it deployed. For anyone who has worked in enterprise IT or who understands how large organizations have historically handled Windows updates, that number lands with the weight of something fundamentally different from the standard advice to keep systems current. IT departments have spent decades building update processes designed around careful testing, staged rollouts, compatibility verification, and deliberate delay. The assumption embedded in those processes that organizations have time to be careful, time to test, time to schedule, is exactly the assumption that Microsoft's new guidance is quietly dismantling. The question worth asking is not whether 3 days is the right number. The question is, what changed in the world outside Microsoft's documentation that made this number necessary? The answer involves artificial intelligence, and it changes how you should think about every security patch that arrives on your computer from this point forward. To understand why 3 days matters, you first need to understand what came before it. For most of the history of enterprise Windows management, the question of when to install security patches was treated as a scheduling and risk management problem with a comfortable timeline. Microsoft released updates on the second Tuesday of every month, Patch Tuesday, and the implicit assumption shared by the industry was that organizations had a reasonable window, typically measured in weeks, to evaluate those updates before deploying them broadly. That window existed for legitimate reasons. Enterprise environments are complex. A security patch that closes a vulnerability in one component can, through the intricate dependencies of a large software ecosystem, create unexpected problems elsewhere. An update that works perfectly on a standard consumer laptop can break a specialized application running on a government workstation or a hospital terminal. Testing was not bureaucratic delay for its own sake. It was the recognition that deploying untested software to thousands of machines simultaneously carried its own category of operational risk. Large organizations built entire disciplines around this reality. Change advisory boards reviewed proposed updates. Test environments ran new patches against representative hardware and software configurations before anything touched production systems. Maintenance windows, scheduled overnight periods when updates could be deployed with minimal business disruption, determined when patches actually reached end-user devices. The timeline from patch release to broad deployment was routinely measured in 2 to 4 weeks, and this was considered responsible practice rather than negligence. Microsoft's own guidance supported this approach for years. Staged deployment was recommended. Testing was encouraged. The update management ecosystem, Windows Server, update services, System Center Configuration Manager, and subsequently Microsoft Intune was built around the assumption that organizations would control their own deployment timelines. So why is Microsoft now recommending something that, measured against that history, represents a dramatic compression of the acceptable window? Microsoft's updated deployment guidance is specific in a way that its previous recommendations were not. The guidance recommends deploying quality updates with security fixes, using a deferral period of less than 3 days, a deadline of 0 to 1 day after the deferral period ends, and a grace period of 1 to 2 days. The combined effect of these parameters is a deployment window that, for devices managed under these settings, completes patching within approximately 3 days of a security update's release. The language Microsoft uses to explain why matters as much as the numbers themselves. Microsoft's documentation explicitly states that devices are considered current when updated within 3 days of a patch's release, and that exposure increases as that window extends. The framing is not simply that patching is good practice. It is that the security value of a patch degrades relative to the time elapsed since its release, that waiting longer does not merely mean taking longer to become secure, but means becoming an increasingly attractive target as the patch window remains open. This is a different argument than the one that drove previous patching guidance. The previous argument was straightforward. Vulnerabilities exist, patches fix them, install the patches. The new argument contains an additional variable: the speed at which the existence of a patch enables sophisticated attackers to understand and exploit the underlying vulnerability. That variable is what changes everything, and it is where artificial intelligence enters the story. Here is the mechanism that Microsoft's guidance is responding to, explained in the sequence that makes it most legible. A security vulnerability exists in Windows. A flaw in the operating system's code that, if exploited correctly, could allow an attacker to execute malicious code, escalate privileges, or access data they should not be able to reach. For some period, this vulnerability is either unknown to attackers or known but not yet weaponized effectively. Microsoft discovers or receives a report of the vulnerability through its security research or responsible disclosure channels. It develops a patch, code that corrects the flaw and eliminates the vulnerability. On the next Patch Tuesday, or through an emergency out-of-band release for critical flaws, that patch becomes publicly available through Windows Update. Here's where the timeline calculus changes. The moment a patch is released, the patch itself becomes a source of information about the underlying vulnerability. Skilled security researchers, and increasingly automated analysis systems, can examine the difference between the pre-patch and post-patch code, a process called patch diffing, to identify precisely what was changed, and therefore precisely where the vulnerability existed and how it functioned. In the pre-AI era, this analysis required significant human expertise and time. It was a task that capable security researchers could accomplish, but one that took hours to days of focused technical work. AI-assisted vulnerability analysis compresses that timeline. Automated systems can perform patch diffing, identify the changed code regions, analyze the vulnerability class the change addresses, and generate candidate exploit code, all faster than the human-led analysis processes that previously defined the timeline. Microsoft's updated guidance explicitly cites AI's role in accelerating this sequence as a primary reason for recommending shorter deployment windows. The practical consequence is that the window between a patch's release and the moment when unpatched systems face exploit attempts from newly developed tools has shortened. The organizations and individuals operating unpatched systems are not simply behind on maintenance. They are operating within an attack window that AI-assisted analysis is compressing from the attacker's side, even as the organizations deliberate on the defender's side. Microsoft's 3-day guidance creates a tension that deserves honest examination rather than dismissal. The argument for patching faster is clear and technically sound. The argument for testing before patching is equally clear and operationally sound. And these two arguments are in genuine conflict. Patches have failed. Not rarely. The history of Windows Update includes documented cases where security patches introduced system instability, broke application compatibility, triggered blue screen errors on specific hardware configurations, or created new problems while fixing the ones they were designed to address. Large organizations have experienced production incidents caused by poorly tested patches deployed too quickly. And the operational cost of those incidents, systems unavailable, work disrupted, recovery operations required, is real and measurable. The organizations that built careful testing processes did so because deploying untested patches to production environments had burned them before. The process was a scar, a response to a documented category of harm that slower, more deliberate deployment had successfully reduced. Microsoft's 3-day guidance does not erase the legitimacy of that concern. It reframes the risk calculation. The question is no longer simply whether a patch might break something. It is whether the risk of a patch breaking something is larger or smaller than the risk of leaving an increasingly well-understood vulnerability open, while attackers equipped with AI-assisted analysis tools build and distribute exploit code. For most security vulnerabilities disclosed in recent years, the answer to that risk comparison increasingly favors faster patching. But the answer is not universal. There are specific patches, specific environments, and specific organizational contexts where testing before broad deployment remains the more defensible choice. Microsoft's guidance acknowledges this implicitly by framing the 3-day window as a recommendation for quality updates with security fixes, rather than claiming that all updates should be deployed without any evaluation. The patch paradox is real. Microsoft is not pretending it does not exist. What has changed is where the balance of risk falls, and AI's role in shifting that balance toward the attacker's side of the timeline is the force driving the change. Microsoft's updated guidance does not exist in isolation. It is accompanied by a set of tools and services designed to make the faster patching timeline operationally achievable rather than simply demanded. Windows Autopatch is Microsoft's automated patch management service that handles update deployment scheduling, ring-based staged rollout, and compliance reporting without requiring IT administrators to manually manage each update cycle. The service is designed to deploy updates with Microsoft's recommended timing while providing monitoring and rollback capabilities that reduce the operational risk of rapid deployment. Hotpatch is a capability available on supported Windows configurations that allows eligible security updates to be applied without requiring an immediate system reboot. For organizations where reboots create significant operational disruption, medical environments, manufacturing systems, customer-facing services that must maintain availability, the ability to apply security fixes while systems remain running removes one of the most significant barriers to rapid patch deployment. Microsoft Intune's compliance policy framework allows organizations to define patching requirements and automatically identify devices that fall outside those requirements, creating visibility into the security posture of managed device fleets without requiring manual audit processes. Taken together, these tools represent Microsoft's operational answer to the paradox that its guidance creates. The 3-day recommendation is not simply a demand that organizations move faster using the same processes they have always used. It is an argument that the processes themselves need to evolve toward automation, toward faster staged rollouts supported by better monitoring, toward patching architectures that reduce the reboot and disruption overhead that has historically made rapid deployment operationally impractical. The 3-day guidance is framed specifically for enterprise environments, the IT departments, system administrators, and managed device fleets that represent Microsoft's primary audience for deployment documentation. It is not a directive aimed at individual users who manage their own Windows installations at home, but the underlying security reality that motivates the enterprise guidance applies to every Windows device connected to the internet, regardless of whether it is managed by an IT department or by a single user who installed Windows themselves. The sequence that AI-assisted analysis enables, vulnerability disclosed, patch analyzed, exploit developed, unpatched systems targeted, does not discriminate between a corporate laptop and a home desktop. The ransomware campaigns that have caused the most widespread damage in recent years have targeted individuals and small organizations as aggressively as enterprise environments. The credential theft operations that compromise email accounts and banking access operate at scale across all categories of unpatched systems. For home users, the practical implication of Microsoft's updated security thinking is not the adoption of a specific 3-day rule. Home users do not typically configure deferral periods and deployment deadlines. The implication is more straightforward. Deliberately postponing important security updates for extended periods, disabling automatic updates, dismissing update notifications repeatedly, deferring patches until a more convenient moment that never quite arrives, carries increasing risk in an environment where the window between patch release and exploit availability is shrinking. Windows Update's default behavior, for users who allow it to operate normally, already approximates the intent of Microsoft's faster patching guidance. The users most exposed to the risk the guidance addresses are not those who install updates when Windows prompts them. They are those who have actively disabled or persistently delayed updates in ways that leave their systems unpatched long after fixes are available. Microsoft's 3-day guidance is a specific response to a specific change in the threat environment, but it points toward a broader shift in cybersecurity that extends beyond Windows Update timelines. Artificial intelligence is changing both sides of the security equation simultaneously. Defenders are using AI to identify vulnerabilities before they can be exploited. Automated code analysis, AI-assisted penetration testing, machine learning applied to anomaly detection. The same capabilities that help defenders find and fix vulnerabilities are available to attackers looking to find and exploit them. The result is an arms race in which the speed of both vulnerability discovery and exploit development is increasing on both sides. Patches that close vulnerabilities are themselves analyzed by AI systems. Exploit code that attacks remaining vulnerabilities is generated faster with AI assistance. The human-paced processes that previously defined both sides of this dynamic are being supplemented or replaced by automated systems that operate at machine speed rather than human speed. The monthly patch cycle, Patch Tuesday, test for 2 weeks, deploy at the end of the month, was designed for a world where the threat landscape moved at human speed. Researchers found vulnerabilities. They reported them. Developers analyzed the reports and wrote patches. Attackers who wanted to reverse engineer patches to develop exploits needed skilled analysts and substantial time. The month-long window between disclosure and broad deployment was, in that environment, roughly proportional to the actual risk. The environment that Microsoft's updated guidance is responding to is different in kind rather than degree. AI-assisted analysis has not made the monthly cycle slightly less adequate. It has created conditions under which the assumptions built into that cycle, assumptions about how long exploitation development takes, about how much time organizations have before patch information becomes attack intelligence, are becoming increasingly unreliable. The question the industry has not fully answered is whether the monthly patch cycle is a model that can be accelerated to meet the new threat environment, or a model that is fundamentally incompatible with a world where patches are analyzed at machine speed. Return to the 3-day figure that opened this discussion. The real story behind Microsoft's updated guidance is not that Microsoft suddenly discovered Windows needs security updates. Every version of Windows has needed security updates for as long as security updates have existed. The fundamental necessity of patching is unchanged. What changed is the perceived speed of the environment that patching operates within. Microsoft's explicit linkage of its shortened recommended window to AI-assisted vulnerability exploitation is not a marketing claim or a bureaucratic revision. It is a documented acknowledgement that the threat landscape, the speed at which vulnerabilities disclosed in patches can be reverse engineered into attack tools, has shifted in a direction that makes the traditional deliberate patching timeline increasingly difficult to defend as adequate security practice. The 3-day recommendation is Microsoft's calibration of where the balance of risk currently falls between the operational cost of rapid deployment and the security cost of extended exposure. It is likely to be revised further as the AI-assisted analysis capabilities available to sophisticated attackers continue to develop. The direction of that revision is predictable, toward shorter windows, toward more automation, toward patching architectures that minimize the human deliberation that creates the delay attackers can now exploit faster than before. Return to the question that opened everything. What changed? The infrastructure of the patching system did not change. The monthly release cycle continues. The categories of vulnerabilities that patches address, memory safety issues, privilege escalation flaws, authentication bypasses, are the same categories that have always required remediation. The mechanics of how updates reach devices are the same mechanics that have been in place for years. What changed is the speed of the adversary. Artificial intelligence gave attackers a capability that the traditional patching timeline was not designed to accommodate. The ability to move from a publicly released patch to a functional exploit in a time frame that organizations accustomed to weeks of deliberation cannot absorb. The 3-day window is Microsoft's response to that capability. It is an acknowledgement, stated clearly in official documentation, that the old assumptions about how much time organizations have between a patch's release and the moment their unpatched systems become attractive targets are being invalidated by tools that analyze patches faster than change advisory boards meet. The monthly patch cycle was built for a specific threat environment. That environment is changing. The question it leaves, the question worth sitting with as the next Patch Tuesday approaches and the update notification appears in the corner of the screen, is this. If attackers can turn a newly disclosed vulnerability into a working exploit in the time it takes an organization to schedule a maintenance window and draft the change request to approve the patch, how long can the old idea of "we'll install it next week" survive? The answer Microsoft's guidance implies is already being written into the documentation. 3 days.